All right, folks. So in the previous video, we talked about the purpose of the impact bead. And we said the impact bead basically controls the flow rate in a way that comes up into the burner head that will do my analysis. But there's more pieces to this burner head than the impact bead. And I'm going to eventually turn to those. But I want to really focus on the burner head as a whole first. So I'm going to draw, or at least attempt to draw, the burner head on the screen for you. And this burner head is typically a long piece of metal with a very thin slit in the center. And then what we see coming from the burner head is the flame. All right, so I'm going to draw the flame up here at the top. And there we go. Okay, so let's talk a little bit about this burner head. What are some of the things that I need to kind of keep in mind when I begin to look closer at an AA instrument and figuring out how it works? Well, number one, the flame on the top for acetylene. Now, we'll get to this in a minute, but acetylene is typically a gas that is used to make the flame. This is the welder's torch. That's basically the same gas that they use, that we use in the AA instrument. So the acetylene flame is on average around 10 centimeters long. So if you look at the flame itself, not the burner head, but the flame that comes from the burner head, you're looking at about a 10 centimeter long flame. And how wide is this thing? This slit that's in the burner head itself. Well, this is typically about 1 millimeter in width. Now, the reason that these dimensions are very important is because the flame area relates to the signal. If you have a shorter flame, maybe sample doesn't go into that flame as much, and your absorbances and your signal begins to change. If you have a distortion in the flame dimensions, whatever distortion that might be, this will affect the signal on your instrument. So, the number one rule here is look. Look at your flame. You want to make sure that this flame is not splitting. And when we say split, that basically means that down here at the burner head, well, we don't want to see areas of no flame at all, areas of darkness. We don't want to see that. We want to see a very uniform base down here at the very bottom. And if we start seeing these splits in the burner head where flame is not really coming up from it, then this is bad news. So you don't want slits. You want to get rid of those. Now, the reason that those appear is because your burner head is getting stopped up. So look at your flame. Number one, do away with the splits. And the reason that those show up is because your burner head has crud on it. This is basically some type of deposit that is being settled onto the burner head, and it needs to be cleaned off. That is how you fix it. So that means you're going to have to stop the machine, take the burner head out, and begin to clean it. You typically clean it, because we're working with metals, with a weakened solution of nitric acid. And this nitric acid does a much better job than soap and water, because it will go into all of these maybe deposits that are showing up in the very narrow slit, right? We're only looking at 1 millimeter here. So if those deposits get inside of that 1 millimeter wide channel, then that creates the splits. Well, nitric acid will love to get down in there and eat that crud off. And that crud is probably maybe some nasty deposits that are being put on there by your sample. Okay? So keep that in mind. Always look at your flame throughout the analysis. The second thing that you want to look for is blue. Okay? So when it concerns the blue color, what you're after here is a blue color that sits at the base of this flame. Right here on the very top of this flame is going to be the hottest part. And that blue color better be very uniform all the way at the bottom. Now, the flames up here at the top, well, this is uneven. It doesn't have to be equal because that's not where the light beam is going to be shining. The light beam is actually going to be looking through the base of the flame down here at the very bottom. And that's why this area is so important in here. Okay? So this should be a very light blue color. And this is where the hottest part of the flame is going to be located. And this is where your measurements are going to take place. So if you do not see the blue all the way across down here at the bottom, then you're going to have to adjust your settings on the gas flow, or you're going to have to adjust the settings on your airflow in order to make sure that works. If these settings are proper, and you've double checked them, and you still don't see a blue area down here at the very bottom, then you have a bigger issue. And that issue could be the burner head itself, or that issue could be something with the mixing chamber in the back of the machine. So you want to adjust that setting until you see that blue color, right? Number 3 is you want to make sure that you have the proper head installed. Now, there's 2 different types of gases mainly that we can use for the AA. We'll get to those in just a second, but one of those is acetylene and the other one of those is nitrous. Each one of these require its own burner. So I'm going to put burner number 1 and burner number 2. You want to make sure that if you use the acetylene gas, that you choose the acetylene burner head. If you use the nitrous gas, you use the nitrous burner head. And they will be labeled and they will look different. The acetylene is the one that's going to be 10 centimeters long. The nitrous flame is a much shorter burner head. It's about half the size. The dimensions, not really important. The acetylene is the most common one that we will use and that you would use out in the field, but nitrous is an option, and the nitrous burner heads are always shorter. They're about half the width of the actual acetylene burner head itself. Okay? The width of them is about the same. 1 millimeter width for acetylene, 1 millimeter width for the nitrous. That dimension's not going to change on you, but the length of the burner head will. So, before you run samples at all, again, you have to look. You have to take the necessary steps. Number 1, do you see splitting that's happening in the flame? If so, you've got to fix that before you go on and run samples. You don't want the flame to split and have dark areas here that no sample is coming from due to some kind of clog that's happening in the burner head itself. Number 2, you want to take a look at the blue color. Is that blue color looking universal all the way throughout the bottom of the burner head? And number 3, did you actually choose the proper burner head? You don't know how many times people have ran samples and standards on the wrong burner head because they just left what was in the machine instead of changing it over to what they needed to run samples with. Okay? A little bit about the flame itself. Let's say that I'm looking down the burner head laterally. Okay? So here is going to be the flame. This is 1 millimeter wide. And here the flame height can be really as tall as it needs to be. There's no really height that's assigned to the flame itself. There's a couple of areas here that we want to talk about. Now remember, down here at the bottom, I said this is your blue area. This is where kind of your sample measurements are going to be made. That blue area is called the primary combustion zone. Primary combustion zone. It is the brightest part of the flame, and it's the deepest blue part of the flame. After you get outside of the primary combustion zone, you then get into the main part of the flame, and the main part of the flame is called the interzonal. So I'm going to draw this kind of pinkish. So majority of the flame here going to be pink, and that pink one is called the interzonal region. That interzonal region is going to be an area of the flame that takes up a lot of space, but it is not the hottest part. So I'm going to put not the hottest. That's given to the blue down here at the bottom. And then finally, you get this area of the flame that's red, kind of up here at the very top, on the outside, maybe in a way. And that red area is called the secondary combustion zone. And the secondary combustion zone is just kind of the reddish orangish outermost parts of the flame. This is the part that flickers back and forth and that can move. And we don't really do a lot of analysis at all through that part of the flame. It's also the coolest. So what's funny is that a lot of people look at that red and orange color and think that it's the hottest, but that's actually the coolest part of the flame itself. So there's three areas of the flame. There's kind of the outermost region that we call secondary combustion. We do not do measurements there. There is an interzonal region, kind of the area between that red flickering, orange flickering piece and the blue piece. That's a kind of a large middle area there. Well, there's some stuff that's going on, but it's not the hardest part of the flame. And then down at the bottom, that's the blue area. And the blue area is the hottest part of the flame, and that is where most of the measurements are made in the atomic absorption spectrometer. This area for the blue, the height here, how tall should that blue piece be? Well, that blue piece is around 1 centimeter in height. Okay, so this you can see with your eyeballs pretty clearly. And that 1 centimeter is there because the detector and the light source have to pass through that 1 centimeter height flame. And that's the whole purpose of lining up your light bulb. You line up the light bulb to make sure that the light will be going through the blue area of the flame. You don't want the light bulb to kind of be pointed up and to go up through here. That's stupid, right? Why would you want to do that? So the detector is over here to the side, and the lamp is over here to this side, and you're aligning the lamp up so that way that lamp can go through the blue part of the flame and hit the detector. And that blue part of the flame is called the primary combustion zone, and that is where the majority of the measurements are going to be made. Okay, so in the next video, we'll continue on discussion of the burner head and the flames and the choices that I have as an analyst.